All right, so compound inequalities is what we are doing in this particular section, which is Chapter 5, Section 4. So compound inequalities. In compound inequalities, there are two different kinds of scenarios. There's the and scenario, and then there's the or scenario. We're going to go over both of those different kinds of scenarios so that we can look at graphs and just what they look like. So first thing here, we've got this and scenario. We'll do probably about 3 examples of each of these different kinds of scenarios. So that way we've got some examples, and then tomorrow there'll be a practice. So the first one, we've got x is greater than 4 and x is less than 6. So we're going to end up having our x in the middle. And on the right side, we want what x is going to be greater than. So we want it to be greater than 4. So we want all of the numbers to go above 4. And then we want what it's going to be less than on... So we want greater than on this side. And then the less than on the other side. Doesn't matter if it's less than or equal to, just that other side needs to be the less than symbol. So again, we're going to put this into set builder notation because this is often how you're going to see it. So you're going to have your variable, your vertical line, and then you are going to have that equation we just wrote. So that 4 is less than x, which is less than, 4 which is less than x, which is less than or equal to 6. So we're going to graph these individually as pieces. So we're going to start by just graphing that first part of 4, and this one actually gives us our number line, so we don't have to create it. So that first number line is going to be that yellow part that I just highlighted there. So I have a point at 4. You should be saying that point should be open because it is not equal to. And I want all of my x values to go more than 4. And there's a reason that we're doing it broken up. Eventually, you should just be able to do it with 1, but that's okay. For right now, we're going to do it with 2 because it'll help us out a little bit. The next part of this is that x is less than 6. So 6 is equal to, less than or equal to, so it should be a closed point. And my x values are less than that, so I'm going to shade the other direction. Now I'm going to put both of those together. So for my last graph, and this is going to be the answer, we've got a closed point at 6, an open point at 4, and then all of my shading for both of those, if I look here across, happens between the two of them. Something like that. All right, so that's the first one. The next one, we're going to start by graphing these ones because I often find that graphing them leads us to getting to an answer faster. So x is greater than or equal to 4. So I'm going to start at 4. Put a closed point, and it's greater than or equal to, so that's why I use the closed point. All of my x values are greater than, so I should be shading to the right. That's that red graph. Next one's going to be orange, and I've got x is now greater than 6. So I need greater than 6, which is going to be here. And shade that way as well. And that's my orange graph. Okay, so now I have to think about this because this is an and scenario. And means they occur at the same time. So and would be like you and your best friend go to the mall. That doesn't mean one or the other of you go to the mall. That means both of you are going to the mall. So I need to look and say, okay, how do these both occur at the same time? Well, I know they're both greater than, so everything greater than that should be shaded. So if I look at this space here, where 4 starts, so far I'm not at an and point. I'm not going, oh yeah, those both happen at the same time. And boom, at 6, something happens. I have a point at 6. So my point at 6 was open, and then everything after 6 is going to be shaded. So I've got that x is greater than 6. Finally, we've got one more here. Again, this is the and portion of these. And again, it's easiest to graph these first because you're going to see the patterns and kind of find where they are coming from. So the first one here, we've got x is less than 4, open point, less than 4. The next one, we have x is greater than 6. So I've got an open point and it goes this way. Again, and means there has to be an overlap. So here, if I try to find where my graphs overlap with each other, here's where my first graph is, and they are not overlapping at all, and here's where the second graph is, and those don't overlap at all. So that means there's going to be no solution. So there is no solution for this particular problem. So, and means overlap. Important. Write that down someplace. And means overlap. The next one is our or scenarios. Again, we'll do 3 examples here. Again, I like to graph first and then put it in set builder notation. I think it makes the most sense to do it that way. Or means you or your friend go to the mall. So it doesn't have to be both of you. It could be both of you, but it's likely just one of you. So the first one here is x is less than 4. So I'm going to put an open point at 4. All of the numbers less than. The next one is x is greater than or equal to 6. So again, put a point there. Greater than or equal to 6. These, again, don't have to happen at the same time. So now I'm going to graph them on the same line. So I'm going to have 4. So I just copied that down. And then 6. And it goes over. So for this one, I'm going to have that my x, and I'm just going to literally copy this down. X is less than 4 or x is greater than or equal to 6. That's all you have to do. So that's scenario 1. For the next scenario, we've got x is greater than or equal to 4. So I'm going to have a closed point and greater than. And then for the next one, I'm going to have a open point because it's x is greater than, x is greater than 6. Open point. So then again, I can graph these on the same line because it's an or scenario. So either one of them can happen. Doesn't matter if they overlap or not. So there's the first graph. And then here's my second graph. So notice I do have them kind of both happening at the same time, but my first graph, that orange graph, covers both of them. I'm including both of those or parts by just talking about my first graph. So for this one, I'm going to use that x is greater than or equal to 4 because that includes both the first part and the second part because they overlap with each other forever. One more scenario, and then again we're going to practice tomorrow. So I've got x is greater than 4, so it's an open point, greater than. The next one is x is less than or equal to 6. Now notice with this one, when I graph an overlap, I end up with the entire number line. So that means that any real number is the solution. If you end up with the entire number line, all real numbers is your answer. So that's it. That's all this section is.